This tutorial series covers the making of a 2D player controller in Unity. This first series includes ducking, ladders, wall sliding, and ledge climbing. It will also introduce you to many of the basic aspects of setting up a 2D game that uses Unity's tile map features. The controller is built using a simple state machine that transitions the player between the various action states we will create. Please feel free to request further features in the comments, and I will continue to extend the controller with the most popular requests. You can also request topics outside the scope of this controller, and I will consider producing standalone videos for them, or possibly even putting together another series. Let's get started. Let's start by creating a new project using the 2D core template. We're going to use the basic 2D option and then set up the universal render pipeline manually so we can see where to find the asset and how it is connected to the project. You can see there is another option named 2D URP that will set up the pipeline asset for you using the appropriate 2D settings. After the project loads, let's open up the package manager so we can install the universal render pipeline package. Make sure you have the Unity registry option chosen at the top and then look for the package called Universal RP. Now that we have the package, we can create the pipeline asset that our project will need to access the new rendering pipeline. Let's begin by creating a folder in our assets called URP. This is where we will store all of the items related to the universal render pipeline. Inside this folder, we can create the asset by bringing up the right-click menu and looking under Create. Underneath the rendering category, we can find the option called URP Asset with 2D Renderer. Let's keep the default name and just remove the word New from the beginning. This will generate two new scriptable objects related to the rendering pipeline. One of them is the pipeline asset, and the other is the 2D data object. The data object is where we can find many of the options that used to be under the graphics settings with the default rendering pipeline. We will come back to these options later when setting up our tile map. Now we need to connect this new pipeline asset to our project. We will do this by looking under Edit to find the Project Settings menu. Choose Graphics from the left panel, and here we can see some of the options that will be replaced by our new pipeline asset. Let's choose the asset by selecting it using the dialog that opens when clicking on the field under Scriptable Render Pipeline Settings at the top. This will warn you that making the switch may take a significant amount of time, but it happened almost instantly for me. Now that we have the pipeline connected to our project, let's save our scene for the first time. We'll call this scene World and put it into the Scenes folder that already exists. We can then delete the original sample scene that was created for us. The next thing we're going to do is set up the Pixel Perfect camera component that will allow us to display old-fashioned pixel graphics correctly in our game. If you're using a newer version of the Unity editor, then this package will already be installed in your project as part of the 2D template that we use to create the project. Now we can attach the Pixel Perfect component to the main camera in our scene. The first option under this component allows us to determine how many pixels in our images will be equal to 1 unit in Unity's world coordinates. We are going to be working with tiles that are 16 by 16 pixels, so we're going to choose 16 for this setting. Let's save our project and then run it for the first time to make sure we don't see any errors. You might see a warning that the scene is being rendered at an odd-numbered resolution, which may cause the Pixel Perfect camera to display improperly. To fix this, we can simply choose a standard even-numbered resolution from the drop-down at the top. Now that everything is running correctly, let's make sure all of our Universal Render Pipeline objects are in the right folder. There's one more settings object that was placed at the root of our assets folder. We can move this object into the URP folder so that all three are in the same place. We're now going to import all of the images that we're going to use for this project. Let's start by creating the standard resources folder at the root of our assets folder. This is a folder that Unity will look for when we try to load resources while the game is running. If we right-click, we can choose the Show in Explorer option to view the resources folder on our computer. This will allow us to copy the images we need into our project. The images are in this repo on GitHub. It's important that we use Git to clone the repo because the images are stored using LFS, or the large file storage format. If we download the repo as a zip file, all we will get is essentially references to the images. We won't have the actual images. This is part of how Git deals with large files in order to make the process of tracking more efficient. So let's copy the repo's URL and then open up a terminal so we can clone the files onto our computer. Choose a location where you want to clone the repo with the cd command, and then use the git clone command to get a copy of the repo. Now we want to open another Explorer window and navigate to the files we just downloaded. Then we can copy the images folder into the resources folder we created in our project. When we return the focus back to Unity, it will automatically import these assets into our project. Notice that along with the images, we are also getting Unity meta files that contain some settings that will be applied to our images. Now that we have the images in Unity, let's take a look at some of the settings that were imported by the meta files. Just like how we set the ratio of pixels to units with our pixel perfect camera, we also want our images to have this same ratio of 16 pixels to 1 Unity unit. On top of this, we also want our images to have a custom pivot set. This is the point that will be considered the origin of the image when it is placed into the scene. By opening up the sprite editor, we can view this custom pivot that was set by the meta file. The default pivot point for images is the center, but we have the custom pivot set to be at the bottom center of the image. This is the point that will act as the position of the character when they are placed into the scene. Finally, we also need to set a few advanced options for each image to ensure that they are displayed correctly by the Pixel Perfect camera. We do not want any filtering or compression to be applied to our images, because this would blend together the pixels, ruining the pixel art look that we are going for. We have the filter mode set to point, no filter, and the compression set to none for every image that was just imported. This is all handled by the meta files. Most of these settings are all identical for the images we just imported, but I'll highlight one exception before we move on. We have a set of images that will be used when the player climbs a ledge. Because of the mechanics of ledge climbing, it is a bit tricky to decide how to handle the animation. What we are going to do is use a larger animation that makes it appear like the player is climbing the ledge, when really they are still technically standing at the bottom of the ledge until the animation is complete. And then they will be instantly moved to the top of the ledge to create the illusion of climbing. In order to do this, the larger image needs a pivot point that is at the lower left. We'll talk more about this in detail when we build the climb ledge action. Let's also take a look at the settings that were imported for the tile map that we're going to use. The tile map also requires the same pixel ratio and advanced settings that our player images needed, but it also needs to be sliced into individual tile assets to be used by the tile map editor. To do this, we first set the tile map sprite mode to multiple so that this image will be used as multiple individual sprites, and then we use the sprite editor to slice the image into tiles. This can be done by slicing the image based on the tile size we're using, which is 16 by 16 pixels. This was all handled by the meta files, but if you're doing this manually for your own images, make sure to apply the changes before moving on. Then you should see that the tile map has been separated into individual tile sprites. We can view these sprites by opening up the drop-down of the tile map image. This reveals the individual tile sprites that we can make use of in the tile map editor. That covers all of the setup we need to do for our project. In the next video, we'll build the prefab object that we'll use for our player, and then we'll set up all the animations our player will need.